That's part of what we really wanted to look into as a big reason of the Subtropical Soil Health Initiative, is to really see, how we could try and minimize, or how we can come to a better understanding of how to minimize soil moisture loss while maximizing some of the other benefits that are touted through cover crops.
This episode of Voices from the Field is the first part of a discussion between National Center for Appropriate Technology agriculture specialist Colin Mitchell and Dr. Alexis Racelis of the University of Texas, Rio Grande Valley about the use of cover crops in semi-arid subtropical environments. In particular, the discussion centers around the Subtropical Soil Health Initiative, which is a research partnership between NCAT and the University of Texas at the Rio Grande Valley to research soil health changes in the Lower Rio Grande Valley. While cover crops are heralded as a regenerative agriculture tool to improve soil health, in drier climates, integrating cover crops into farming systems can be challenging. Colin and Dr. Resells discuss whether cover crops can even be detrimental in some scenarios and steal water from cash crops. Let's listen.
Hi all, my name is Colin Mitchell and I'm a sustainable agriculture specialist out of NCAT's Southwest office based in San Antonio, Texas. We're here today with Dr. Alex Resells, and he is an associate professor with a joint appointment in the Department of Biology in the School of Earth, Environmental, and Marine Sciences at the University of Texas at Rio Grande Valley, which we will call UTRGV for brevity's sake. Alex leads the Agroecology and Resilient Food Systems program focused on participatory research and education in restorative agriculture, agroecology, and soil conservation and management, and food and farm justice. The mission of this program focuses on capacity building for students, community partners, and farmers through informed action, access to learning opportunities, and community engagement. Dr. Resells is also now a board member of NCAT, and he also leads the UTRGV team on NCAT's Subtropical Soil Health Initiative, which is funded by a USDA NRCS Conservation Innovation Grant. The Subtropical Soil Health Initiative focuses on research and education around cover crops and other methods in row crop farming systems to improve soil health in subtropical semi-arid regions. The lion's share of our work takes place in the Lower Rio Grande Valley of Texas, which is where UTRGV is, near the US-Mexico border. Alex, thanks for joining us.
Yeah, my pleasure, man.
Yeah.
Thanks for having me, Colin.
Yeah, thanks for being a part of it. I guess let's go ahead and dive in a little bit. I think it's good for always in these podcasts for our audience to know a little bit about you and who you are and how you came to be where you are. So what led you to an academic career in agroecology, resilient food systems, and building soil health?
Well, Colin, I mean, depending on how far you want to go back, but I don't think any, as an immigrant to the US, I don't think any of my friends or my relatives ever aspired to be an academic, right? I mean, I think my parents pushed kind of a medical degree, something that had kind of a high rate of financial return. But at some point, like in my early career as an undergraduate at the University of California, Santa Barbara, I realized that, I didn't really have the chops to do a medical career when I had such a passion for the environmental studies, like being outdoors. I've always had an interest and passion for like urban farming. As growing up as a kid, we had, chickens and we had vegetables in the backyard. And my grandfather who lived with us really showed me the ropes in terms of how to care for plants. And so even though I didn't grow up on a farm, I had this kind of care for the land philosophy that I carried throughout my career, and of course really guided me in terms of the kinds of classes I gravitated to. UC Santa Barbara is not an ag college, but the University of California system does have a cooperative extension. And I actually worked as an intern for UC Cooperative Extension. I worked in avocados and to some degree in biological control of pests. And then from that point forward, I mean, I just kind of always worked in ag-related studies. I did my senior thesis on coffee in Costa Rica, looking at insect diversity in organic coffee farms. And then, I did my master's in agroforestry and my PhD in agroforestry and natural resources management, agroecology University of California, Santa Cruz. And so my passion has always been to kind of work at the interface of agriculture and human interaction with these agricultural systems. So, I mean, I think that's where it all started. Now, of course, when I first graduated from UC Santa Cruz with a PhD, my first job was at the U.S. Department of Agriculture as an ag scientist. And that's 100% research position. I really enjoyed my time there, and that kind of those kinds of positions are really kind of designed to inform action with growers, action with land resource managers, and then of course an opportunity came up to become an academic scientist, which is an entirely different beast. It actually allowed me to work with students more closely, kind of to teach as well. I mean, that wasn't in my charge as an ag scientist with the USDA, but it really kind of renewed both my focus and my interest in sustainable ag, because it's not only of personal interest, but here in the Rio Grande Valley, it's of local relevance. As you know, Colin, the Rio Grande Valley its history is defined by agriculture. And so being in an area that's so agriculturally rich in both, productivity and its history, it just seemed like a very great, a very relevant focus of my career once I started here in the university. But that was about 7 years ago. So, I think based on my training and based on my passion, when I first started at UTRGV, I just launched that program in agroecology and resilient food systems, and it's been pretty successful thanks to the collaborations that I've had with NCAT and with local area growers.
Yeah, that's great. And don't give yourself, don't make yourself sound too old, Alex. You're still, you're not that old.
It sounds old, right? I mean, after all, after all of the kind of the experiences that I've had, I always tell people sometimes with folks, just like cars, it's not the age, it's the mileage, right? And so, I feel like even though I might be a relatively quote unquote young scholar, I've had a lot of mileage, and it's very helpful for me too to know what is a good use of my time and energy. And so I think that and then of course, as you know, Colin, I'm a father of 2 children, and that focus on sustainability, just thinking about whatever contributions I can make to their future, to me is also important, right? And so that also comes with a little bit of age and mileage. So I think I failed to mention that in my response to your first question, but I think that's absolutely a big part of it. It's just that kind of the drive that I have in terms of bequeathing whatever I come into contact with for my own children's future. And so anyway, that's a big part of that equation, Colin.
Yeah, definitely. That makes total sense.
Part of what I do, I always tell people, I actually have a second job, and they're like, "Oh, what?" And I was like, "Actually, the work I do here is my second job." I had another job that's even more important, is making sure that my kids are in good hands. And the truth is that that's part of that work, and it's something that I can feel proud of and know that I'm doing, my small part.
So you work with farmers in the Rio Grande Valley on developing soil health management strategies, began, well before I came to NCAT back in 2018. Can you describe the work you have done leading up to this project, with or without NCAT? I know some of that has been with us, and how it helped shape the Subtropical Soil Health Initiative. And, you really felt that need for the Subtropical Soil Health Initiative was there.
Right. So as I mentioned, Colin, I think most of my career, both as a student and also as a young scientist with the USDA, an early career scientist, it really was about working with people and understanding the kind of reality of decision making when it comes to managing ag systems or when it comes to managing natural resources. And so, I really think that kind of participatory action work, that we do in this program in particular, it is really the foundation of work that really can have the impact that we hope as scholars to have, which is that we can work with folks who can take the information, or we can generate information together in a way that makes the understanding and the shared learning, that makes it relevant, right? I mean, there's a lot of research that, of course, I've participated in, throughout my studies and careers that, may or may not make an impact. It might result in a published paper somewhere, but the truth is that publications don't make those kinds of decisions. I mean, it can help reinforce what we know. But the truth is often that those kinds of works don't take into consideration the myriad of different factors that come into decision making at that level. And I think that I mentioned that because that framework of being able to participate with farmers and being able to come to a shared understanding of actually what happens on the ground, that is at the foundation of the Subtropical Soil Health Initiative, is that kind of participatory research, action research framework, where we're working directly with farmers at a farmer's scale, to understand, can this actually work? And I'm not talking on a small experimental field station, but can this actually work in terms of providing the benefits that we think they provide, in terms of soil health, and whether or not those benefits actually come into conflict with what the farmer is wanting, which is, improved production, resilience to disasters, or resilience to kind of sudden changes in environmental conditions. That might not even take into consideration kind of these larger kind of geopolitical forces like prices and markets and things like that. In those conditions, can something like soil health management systems really work? And it has proven to work in other areas of the country, but it's hard to take that understanding and just apply it everywhere, right? And so in this area, as you know, Colin, this is an area with the highest concentration of Hispanic farmers in the country. And it's also an area that is so unique, so different from almost everywhere else in the US, besides maybe South Florida and Puerto Rico, that really we can't just take lessons learned from Iowa farmers and bring that to South Texas, because it may not be appropriate regionally or climatically or agronomically, and it may not be appropriate culturally, right? And so those kinds of issues are some things that were already kind of brewing in my mind. And then, of course, my personal approach to my career, that I think that those are the kinds of issues that really help shape the framework that we adopted in SSHI.
So you just mentioned that some of the challenging conditions of the Rio Grande Valley, and maybe that's why a lot of some of the other recommendations from around the country don't work. And I feel like when you try to express these challenges to a lot of people, they think they know what the valley is going to be like. Say it's semi-arid, it's hot and humid. Can you speak a little bit more to some of the aspects that make it such a unique and challenging environment to farm in, and why most cover crop recommendations don't apply to the valley? I think a lot of our listeners, may have never been to the Rio Grande Valley.
Yeah. So if you have never been to the Rio Grande Valley, I have to encourage you to come to visit. It is truly a unique place in the country, not just agronomically, but culturally. There's a lot going on here in this region. I always tell folks it's kind of one of the best kept secrets in the U.S. The truth is that it's not much of a secret anymore. I think people, read about it in the news sometimes for not for other reasons, right? I mean, unrelated to farming, but it's really become kind of a hotbed of issues that the rest of the country face. As I mentioned earlier, this is not just something that's happened now. I mean, farming and agriculture has a long history here in the Rio Grande Valley, very much similar to the histories of other places in the country, which had a lot of other issues besides can you grow, but how do you deal with labor? Who's actually doing the work? And so a lot of those issues, of course, have legacy in places like the Rio Grande Valley, in places like the Central Valley of California, places like the Central Valley, Central Florida, the U.S. South, and so these are all kind of issues that here in the Rio Grande Valley are at the forefront of how we think about agriculture, and in the sense that using a kind of a systems understanding of agriculture. So I know that NCAT, for example, is really conscious of issues of race and diversity and justice. And like I said, we've been learning a lot here in the Rio Grande Valley, and a lot of that understanding can kind of transfer over to have some relevance to situations across the country. All of that said, Colin, I mean, what makes it such a challenging environment to farm in is because it is considered an arid subtropical area, the kind of drier climates with consistently warm climates make it very difficult. Things of that maybe folks from other parts of the country don't consider. Like I'll give you an example. Here in the Rio Grande Valley, we rarely get a real prolonged freeze period. We did get one, of course, this last February, which was the latest freeze we ever had on record. But for the most part, it's fairly mild in the winters. We're talking 70-degree days in January, and then it's extremely hot in the summertime. That might seem idyllic for farming, but when you have consistent year-round pest pressures, where you don't have the quote-unquote benefit of a deep freeze that would kill off and knock back insect pest populations, you just have the prolonged persistence of things like pests, insect pests, and weeds that, of course, make it really challenging to farm here. Moreover, I mean, we have these extremely hot and humid conditions in the summertime, where a lot of rain will come down in these large storm events. And then, of course, the temperatures commonly exceed 100 degrees that make it extremely difficult to farm in what is usually the sweet spot for the rest of the country, right? And so what makes it, all being said, farmers down here don't necessarily have learned about how to farm successfully in our region. This is all kind of done by on-the-job learning, very few publications out there about how to plant cover crops in 100-degree temperatures, where soil temperatures exceed 120, for example. And I think a lot of that is just kind of learning as we go, right? And so that's part of what we're doing now in our work with Subtropical Soil Health Initiative, and our work with our upcoming project. It's a larger on-farm demonstration, which I know we'll talk about a little bit later. But I think that's what makes it a real challenging environment. And, we don't have much intellectual capital being invested here about understanding those conditions, right? I mean, you've got a lot of resources up in the Pacific Northwest and Midwest where they've done, research all across the region, and to really kind of hone in on strategies that are appropriate for there. But as I said earlier, Colin, we can't just take that understanding and bring it down here, right? When we tell people, hey, we're cover cropping in the summertime, when most places in the country are actually, harvesting or planting at that time. I mean, so that's just an example of how challenging it is to farm in this region. That said, the Rio Grande Valley is considered an agricultural mecca for the rest of the state. I mean, we grow tons of vegetables, a lot of fruits. In fact, the Rio Grande Valley is the statewide leader in the production of fruits and vegetables. But those fruits and vegetables usually come between the months of November through May, and so opposite from the rest of the country. So those are all kinds of the biggest challenges. I think when people come to the Rio Grande Valley, and they come like in November or December, they'll be so surprised to see this vibrant, productive agricultural mecca that is the region.
Yeah, it was even surprising to me. And, I grew up in San Antonio, Central Texas, and even just seeing the difference, 4 to 5 hours south is pretty stark. I didn't think it'd be hotter than San Antonio, but it's a weird, it's like there's a conflicting thing where it's very dry, but it's also very hot and humid at the same time. And so it's definitely, I mean, I haven't farmed in the valley, but it's the most challenging environment I've been in where I've seen farming take place. And I always explain to people, winter in the valley is the rest of America's summer for the most part. It's just pretty extreme. I feel like it operates on an area of extremes. Not cold, obviously, but in heats and dryness, but also humidity.
Yeah, I mean, and when we say the valley, we're talking about this 4-county area along, the U.S.-Mexico border. And of course, that's a pretty wide swath. I mean, Texas is a big state. So you're talking 4 counties. Probably those 4 counties are as big as many of those small states in the Northeast. We're talking about more than 2 million acres of farmland in that region alone. And there's a big difference too when you go from the wetter east side of the region and then the drier west side of the region. So yeah, I mean, there's a lot of diversity even within that region that also make it challenging. And so, it's not just so there's a number of factors. There's the kind of unavailability of water, right? I mean, only about 700,000 acres, and of that 2 million acres is actually irrigable. The rest are dry farmed. There's also this kind of persistent pest population of both insects and weeds that make it difficult. And then you factor in, kind of some of the variable challenges that include access to labor, that include rising and changing costs of inputs. You have kind of these volatile markets, and then being a little bit farther away from some of the central hubs of ag is also a challenge, right? I mean, almost all of our food and products go northward, and we do send a few things down into Mexico, but for the most part, a lot of that food and fruits and vegetables that I mentioned, they're export in terms of they don't really stay in our region. So I think all of that, all in all, it makes it a really kind of difficult and challenging environment to farm in, and not just to farm in, but to kind of conceptualize a sustainable food system, which we often talk about when we have these conversations, Colin. I will just repeat my initial point though. All in all, I mean, it's challenging to farm almost everywhere you go, right? I mean, and then you add in the unpredictability of climate these days, and kind of the increasing scarcity and price of water. Farming is hard enough, but I think farming in the Rio Grande Valley has an extra set of challenges that if you can overcome, you can really grow food well here.
Definitely. So, we work quite a bit with dryland farmers, almost exclusively. We have worked with vegetable growers and irrigated growers in the past, but I feel like those dryland farmers, whether it's organic or non-organic, have kind of a special set of challenges because they really have to time their moisture. They have to manage their moisture, the timing of their planting. What does that process look like if, for our listener out there who may or may not be involved in dryland farming, at least so they can see how that works within the Rio Grande Valley and those timings? What does that process look like at planting time?
So I think I could probably say this and it apply to almost all dryland farmers across the country. I mean, there's a lot of areas in the country that still don't have access to water. So you just have to rely on weather patterns, being able to predict climate, which have become increasingly difficult, right? Like, as I mentioned, in the last year alone, we've had, this historic freezes, prolonged freezes, which almost never happen in our region. We have had a hurricane last August, and so the predictions are that we're going to have about the same amount of rainfall every year, but it's just going to come in large storm events. This year, for example, I mean, man, we've had more water this year than we've had in, I guess, last 3 years combined, minus that hurricane we had last August. So, I mean, we've had an extremely wet year this year. So I think it's important to note that, dryland farming, without having a safety net of being able to turn on a water valve, I think that's going to be hard anywhere you go in the country. I think what makes it particularly challenging is a lot of these dryland farmers farm, commodity crops where the profit margins are pretty thin already. You're talking about corn, cotton. And here in the Rio Grande Valley, the region is the largest producer of sorghum in the country, a lot of which is being used for feed. We also have sunflowers, canola, like those kinds of commodity crops that aren't necessarily high value crops, which kind of complicate the calculus because, you know, every time you have an input, it kind of chips away at the very thin profit margin. You definitely want to make sure that when you plant your seed, that it gets the most optimal opportunity to germinate. And then, of course, once those germinate, you want to make sure as best you can that they grow and that they produce the product that you want, right? I mean, ultimately, that might mean the management of nutrition. That might mean making sure that you try to manage weeds or competitors out on the farm or the field. So that might mean you're putting in and amendments to the soil or using timed herbicides. I mean, those are all things that, you know, kind of come with the challenges of dryland farming. Basically, the margin for error is very small. And you want to make sure that you kind of optimize the climate, or you optimize the timing so that it matches the physiology of the plant, right? So I'll give you an example. Here we have some of the earliest cotton in the country, right? I mean, you're harvesting cotton probably by June, July. I mean, we're harvesting cotton now in August. Most farms are now harvesting cotton, which is a lot earlier than a lot of other places in the country. I mean, so it's a matter of timing because, you know, that cotton needs an optimal temperature. You know, it needs kind of an optimal day length. You know, these kinds of environmental cues. And, you know, they might shift a little bit here in the Rio Grande Valley because it gets warmer sooner. You know, but, you know, the Rio Grande Valley has a lot of the earliest crops in the country because of the climate. So you definitely need to time all of that. And not just that, I mean, commodity crops often rely heavily on machinery, right? And so large tractors to get in there and harvest plant as much as you can in one single tractor pass. And so when you're dealing with kind of sandy clay loam soils that have a lot of clay, which are typical of riparian areas near a river, you're going to have some trouble getting in if the soil is real moist. So all of that factors in. So whenever there's a storm of brewing, you're like either praying for rain or hoping that it doesn't, or depending on where you are in that growing process. These are all kinds of challenges that a lot of folks don't really think about. I'll be very honest. You know, I think a lot of folks are not really kind of thinking. They might be thinking, okay, well, how do we manage pests in a very specific way? Or how do we improve pesticide applications in a specific way? But this goes back to thinking about kind of with a systems approach on what are the true challenges, collective challenges that farmers face, because sometimes decision making is based on that calculus. You know, I mean, should I pull my crops out now, or should I let them go out a little bit longer and risk maybe losing them because of a hurricane coming, you know? So these are all kinds of major challenges. In terms of that process, Colin, it usually kind of happens, you know, in pulses, right? There's this like rush to plant and then rush to harvest. And then there's this downtime between crops that I think we're trying to fill in with this idea of cover cropping. You know, cover cropping to add nutrients back into the soil, to keep kind of living roots in the ground to help prevent erosion, and then to build up kind of that soil health that will lead to kind of improved production, improved water retention, kind of improved pest management of weeds and other insect pests. So that's where we're working right now, Colin, in terms of, as you know, that Subtropical Soil Health Initiative is really trying to figure out how we can employ those soil health management principles in that interim around outside of that of the commodity crop season for dryland farmers.
Yeah, which brings us to, which I think is our central theme of this podcast, at least our episode. And it's some feedback we got from farmers that I found interesting and, you know, never considered. I mainly worked on vegetable farms when I was farming, or agroforestry farms. And a lot of the local farmers, you know, down there don't use cover crops, especially in dryland systems. And the reasoning they were not using cover crops is because they said they steal water from the cash crop. Where does this logic come from? Because it is completely opposite of, you know, the benefits are always touted to crops. People are always like, just go plant them. You'll build your soil health. You'll see, you know, greater returns and all these things. But I have never heard until we started doing this project that they could steal water. Yeah, would you want to continue on with that thought?
As you know, Colin, your plants only require a few things to grow, right? I mean, they require some carbon dioxide, sunlight, and water. That's the basic building blocks of photosynthesis, right? And so, if you have enough carbon, I mean, of course, there's some other things that factor in there, like micro and macronutrients, kind of, that help, but in the end, what really is the essential requirements for photosynthesis is just water and carbon dioxide, really, And so whenever we have cover crops in the ground, they have to have water. And in areas like, South Texas and the Rio Grande Valley, where water is the limiting factor, I mean, that really has to be the first consideration for most farmers, right? There's all these little strategies of how to conserve water. Some of them are, building beds and leaving them, to try and create these mounds where, you can perhaps knife into when the time of planting and there's some moisture underneath there. There's all these things. But the moment you introduce kind of a non-crop plant or a cover crop to get into those soils, all of a sudden there's a need for that water, whatever water is in the soil. And so, I mean, I don't think it's just kind of comes from anywhere. I think farmers have a good understanding of what it requires for them to grow their crops. Dryland farmers have that understanding even more than I think most growers do, because they understand that is the limiting factor for them. So, I mean, I think logically, if you just think about it, just like kind of from a plant physiology standpoint, obviously any plant in that soil is taking up water, and they transpire that water, and they release that water into the environment, right? I mean, it's out of the ground, goes through the plant, and often that evapotranspiration process that happens is happening whenever you see plants in the ground. Now, here in South Texas, it happens a lot faster because evapotranspiration, it is in part related to temperature and humidity, right? So when you have high temperatures and it's dry, that is really going to exacerbate this evapotranspiration. Those plants, whatever's in the ground, is really going to want to get more water because it's losing water at higher rates, right? And so if you plant cover crops and you don't get much more water after that, which a lot of farmers increasingly can't count on, then that can be an issue. And as you know, that's part of what we really wanted to look into as a big reason of the Subtropical Soil Health Initiative, is to really see, how we could try and minimize, or how we can come to a better understanding of how to minimize soil moisture loss while maximizing some of the other benefits that are touted through cover crops.
Tune in next week to hear more about the research results of the Subtropical Soil Health Initiative and about the direction of research going forward in the Rio Grande Valley. That's it for this episode. Thanks for listening. Additional information about this episode and related resources can be found at atra.ncat.org. Don't miss an episode. Subscribe to Voices from the Field wherever you get your podcasts. I'm your host, Rich Myers. ATRA, Voices from the Field, is produced by the National Center for Appropriate Technology, headquartered in Butte, Montana. It's supported by the USDA Rural Business Cooperative Service as part of NCAT's ATRA Sustainable Agriculture Program. Any opinions, findings, conclusions, or recommendations expressed in this recording are those of the participants and do not necessarily reflect the views of the USDA or NCAT. We'll catch you again next week, and until then, keep on farming.